Good afternoon, geometry students. Sorry that I couldn't be there with you today, but I decided to do this little video so that I could kind of go through the lesson that I would have gone through with you. I know the substitute is going to assign that you read section from the book and then try the homework problems that I would have assigned you if I was there, but I know reading a textbook in math can be intimidating, so I'm just going to go through the lesson. If you can kind of follow this video till the end, then you should be prepared to do the homework. Okay, those who are watching from block 1, it's just a review of what we did on Friday. So we're going to be proving geometric statements today, and I'm going to start with this example where first of all you'll notice on the screen, and I'm going to use my mouse here, my marker, to point things out, that we have been given a diagram with a segment and 3 points, A, B, and C, where clearly B is between A and C. We have also been given a statement here that the length of AC is equal to the length of AB plus the length of AB again. Now, because that is given information, we just need to accept that that's true. That's what given means. You're being told that something is true. We are then being asked to prove that AB must equal BC. Okay. Now, like lawyers in a courtroom, we are going to try to put together a logical case, and it is already shown here in the book how we lay out a geometric proof. We're going to start with 2-column proofs, where in the left-hand column we give a statement, and in the right-hand column we give the reason for that statement. The first statement, AC equals AB plus BC, AB plus AB, is given. So we're going to fill in the statement given, always on the first statement. The reason is just given. The second statement, AB plus BC equals AC, may not be as obvious as the given statement, but when we look at the diagram, it should look familiar that the distance from A to B plus B to C adds up to the total AC. What postulate do we know from past lessons makes that true? That would be segment addition postulate. So we're going to put that in as our reason to make that statement. The next statement, AB plus AB equals AB plus BC, that may seem to come out of nowhere. However, there are some properties of equality that I mentioned to you guys that is going to help us put this together. The property I'm going to use for this step 3 is the transitive property. And the way I can justify this is if you read statement 3, AB plus AB equals AB plus BC. Now, where else did I see AB plus AB? Up here in statement 1. And in statement 1, that phrase was equal to AC. Then in statement 2, AC was equal to the phrase AB plus BC. So therefore, I can take the first phrase, AB plus AB, since it's equal to the second one, and the second one is equal to the third phrase, and say that the first phrase is equal to the third phrase. That's the transitive property that links 3 objects together in equality. The first is equal to the second is equal to the first must be equal to the third. So we're going to say that this statement number 3 is true because of the transitive property. I'm going to put that in right here. It's the transitive property of equality. Once we have statement 3, to get to statement 4, you might notice that statement 4 looks a lot smaller. The reason for that is we have simply subtracted both AB's from each side of the equation. And what do we call it when we say we can subtract the same thing from both sides of an equation and not change the balance? That's called the subtraction property. So we're going to fill that in for statement 4, why we can support statement 4, the subtraction property of equality. We have subtracted AB from both sides of the equation. And that is the proof For this problem, we don't have to say proof at the end. We have just supported all of our statements leading to the statement that they wanted us to prove. Okay, let's try another one involving segments. This one says that the steps are partially filled in, even the reasons are partially filled in, but we're going to figure out the missing reasons. Take a look at the diagram. You have to notice that you have a segment with T between S and U, and in the given statement, we are told that T is the midpoint of SU. So T definitely is halfway between S and U because that's the definition of midpoint. That's something to make a note of. When you read the given information, try to think about everything it tells you. So, given this diagram, we are supposed to prove that the value of x in those algebraic expressions will equal 5. So we're going to start with the first statement being what was given. T is the midpoint of SU, and you will always start your proofs with the information that is given, and the reason you will put for that first step is always given. The second step, you can see, has been stated that ST, the segment, is congruent to the segment TU. How would we know that those two are congruent? Based on the definition of midpoint, since T is the midpoint, then the segments on either side of T are congruent. So that's the second reason given right here. Statement 3, ST is equal to TU. That's a slight variation. Just because we know that two segments are congruent, we also know that their lengths are equal. So we're just translating from segments being congruent to lengths being equal using the definition of congruent segments in step 3. Now the next step, number 4, says 7x equals 3x plus 20. How would we get from step 3 to step 4? It comes from examining the diagram and realizing that the length of ST is labeled with 7x, and the length of TU is labeled with 3x plus 20. So we are simply taking these expressions and placing them in the same spot of the equation as their equivalent expression. So what would we call that? We would say the reason we can do that is substitution. The substitution property of equality states that if two things are equal, you can use one in place of the other. And in fact, we're doing two substitutions at the same time. We're putting 7x in place of ST and 3x plus 20 in place of TU. The next step is up to us to figure out what we are going to write. But we're supposed to use, here's the hint, the reason that is stated for step 5 is subtraction property. So what will we subtract from both sides of the equation in order to get to x equals 5? I propose we will subtract 3x from both sides, and the result that we will write into the statement for number 5 is 4x equals 20. So by subtracting 3x from both sides, we have a new variation on the equation. And we can support that with subtraction property. And finally, since 4x equals 20, we can now deduce that x equals 5 using what property of equality? How do you go from step 5 to step 6? You have to divide both sides by 4. So we're going to say that the reason we know x equals 5 at the very last stage here is the division property of equality. Now, when you're taking notes, if you abbreviate a little bit, you just say division property, that should be acceptable. I just want to make sure you understand the concepts here. Now, for our next example, we're going to use some of these properties of congruence that I had introduced you to the last time we were together, but we didn't actually apply them yet. They are reflexive property, symmetric property, and transitive property. They apply to both segments and angles. The reflexive property basically says that any segment is congruent to itself. which means it's like one object looking at itself in the mirror. Any object is congruent to itself, really. So the reflexive property, it's like a reflection looking in the mirror. Symmetric property says if two segments are congruent in one order, you can also state their congruence in the other order. You can swap them on the sides of the congruence symbol, and it's still true. If segment AB is congruent to segment CD, then segment CD is also congruent to segment AB. There's a symmetry to the congruence. The transitive property links three segments together in equality, like a train with an engine and a caboose and a car in the middle. If segment AB is congruent to segment CD, and segment CD is congruent to segment EF, then segment AB is congruent to segment EF. The first is congruent to the last because it is congruent to the middle, and they're all congruent. That's the transitive property. Reflexive, one object equal to itself. Symmetric, two objects swapped in order. Transitive, three objects linked together like train cars. And the same applies to angles. So let's take a look at one more example of writing a proof. This is something you'll find in the text. We're given a segment with endpoints A and B, and we are given that M is the midpoint of AB. So of course, the first statement we're going to make in our proof is to state that M is the midpoint of AB, and the reason is given. We're just going to fill that in. The second statement here, that segment AM is congruent to segment MB, comes from knowing that M is the midpoint. The definition of midpoint tells us that if M is the midpoint, then segment AM will be congruent to segment MB. So we're just invoking some earlier definition that we already know. Then in step 3, we translate it from congruence of segments to equality of length, because when we know two segments are congruent, then we know they have the same length. And so the definition of congruent segments is the reason we can state that AM equals MB. Step 4 states that AM plus MB equals AB. AM plus MB equals AB. When you look at the diagram and you think back to what we already know, that comes from the segment addition postulate. So that's the reason that supports that statement. Statement 5 is very similar to statement 4, except instead of AM plus MB equals AB, it says AM plus AM equals AB. It looks like there's been a substitution here. In place of MB, we have put AM instead, and that comes from statement 3. If you combine statements 3 and 4 together, you get statement 5. Because in statement 3, we are told, we have stated that AM and MB are equivalent. So we can use AM in place of MB, and that's called substitution property of equality. Finally, we have from step 5 to step 6, AM plus AM becomes 2AM. You might think that's adding, because that's typically what we say. In algebra, we would say we combined like terms, we added them together. Your textbook might call it substitution because you're taking one expression, AM plus AM, and you're replacing it with an equivalent expression, 2AM. We could write just combining like terms. I'll be okay with that. But if you see the book calling it substitution, then that's why. And finally, so we've actually proven part of what we were asked to prove, because part of what we were asked to prove was that AB equals 2AM. And so that's part of what we were asked to prove right there. The final statement is to then translate that to just AM equals 1/2 AB. And the way we do that is simply by multiplying both sides by 1/2. So that's the multiplication property of equality.